So what are the continuous sub array here? The continuous sub arrays for 3 to 3 1 2 4 is 3 3 1 and 3 1 2 and then 3 1 2 4, like same way, like for the 1 it will start from 1 1 2 1 2 1 2 4, then 2 and 2 4, then 4. So what are the actually problem say that we have to find the sum of minimum of sub array. So the minimum here in this sub array is 1. So in the same way the minimum of this sub array is 3. So 3 plus 1 plus 1 plus 1, if we'll add all those, it becomes 17. So the one way to find is the brute force. So you just create a two loop and create all the possible sub array and keep the track of minimum and add all those minimum. So the linear solution, let's take an example of this this array. So you have 2 9 7 8 3 4 6 1. So now suppose take an example of 3. So what are the sub array where we can use 3 as a minimum? So those sub arrays are it will start, we can't use 2 because 2 will be the minimum. So it will start from 3 9 3 no 7 9 7 8 3 9 7 8 3 3 is the minimum here. The same way 9 7 8 3 4 and 9 7 8 3 4. So all over here we are using 3 as a minimum. So 3 here, 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 3 here. So total sub arrays are 12. If you count all, this is 12. So now it's become very easy. The total sum of all these 12 multiplied by 3 will be 36. So if we know so look at this now. So now if you notice all the sub arrays are from this point to this point. So actually it is we are looking for the what is the previous minimum of the of 3 and the next minimum of the 3. So the previous minimum is 2 and the next minimum is the 1. So if somehow we know that what is the previous minimum for 3 and what is the next minimum for the 3 and at what index they are. So if we know that, we can calculate, we don't have to calculate all this, we can simply calculate we calculate the this 36, we can get the value. Let me show you how. So so what is the previous minimum, what is the index of previous minimum? Previous minimum index is index is 0 and then next min index is 7. So if we calculate like what is the current what is the where is 3, it is at 4. So we will say 4 minus 0 multiplied by 7 minus 4 multiply by what is the value of for what is the minimum value for which we are calculating, that is 3. So this become 4, this will become 3, this become 3, this is total 36. So now the question is how we can calculate the what is the previous minimum for 3 and what is the next minimum for 3 for this position. So if we can store somehow the what is the previous and the next minimum for this one, then we can calculate. And suppose so if we remember the logic of trapping the rainwater, so if we have the same thing, we need to know the what is the previous minimum for this this position and what is the next minimum for this position. We can store that one in the two array. One array will store the all the previous minimum for each and the other array will store all the next minimum for 4, and then we go again and calculate all this. So let's see, and to keep the previous minimum, we use the stack with the concept of mono. So we'll fill the previous minimum array and the next minimum array using the concept of monotone stack, which we have seen in the previous few problems. So here is the pseudo code. We have we took two array, previous minimum and then next minimum. Let's fill the previous minimum. So we are going from left to right, and this is a simple for loop, and here is the concept of monotone stack. So monotone stack, if the condition satisfy, we keep popping out the elements from this one, from the stack. So here, if the peak of the stack is greater than the current value, that means we find the at least one minimum for whatever the elements present in the stack. So as soon so we remove that one, and we remove the top of the stack, and we will keep doing that because it could be possible that the current is the minimum for the other which is trapped inside the stack. So that's why we have the while loop, and this is the very generic code for the monotone stack. So once we remove all the greater value, which we popped out all the greater value present in the stack, which are greater than the current value present at I. So once we have that, then we'll put that for the current I, for the current index, what is the where is the minimum value present. So this will do that. So let's do the dry run. We have this array 2, 8, 9, 3, 4, 1. So now when I equal to 0, we'll check first this condition. So right now the stack is empty, so it's a false. It will go directly and update the previous list. So as it is empty, so we're gonna put -1, and then it will go and update the array. So we are gonna actually then it will go and update the stack. So stack, we are putting the index just for the clear visibility. We are gonna put like value also. So index is 0, value is 2. Now the 8, now I equal to 1 and the value is 8. So it is coming again, it's a false. So the peak of array is the peak of a stack is not greater than the current one, which is 8. So it will go and update. So it's a false, and gonna update the previous list. The previous list over here is peak of the stack. So right now it's not -1, but we'll check the peak of the stack. So peak of the stack, what is the index in the stack? Right at the top is 0. So we're gonna put 0 here, and now this case it will go and update put on the top of stack. So will be 1, 8. So now 9, when 9 is coming, 9, so 9 is still is bigger than the previous one. So this statement is still false. So it will go and update the previous list. So what is the top of the stack? The index is 1, so we're gonna put 1, and then this will go and update the stack also. We'll put on the top of stack. So it's a 2 and 9. Now we have I equal to 3 and the value is 3. Now this time it's gonna be true because 3 is less than the top of the stack, so which is the value is 9. So we are gonna pop all the value which are greater than current value 3. So we are gonna pop out all the value which are like this will go out, but but now top of the stack is 0, the value is 2, which is less than 3, so it will stay here. After popping out everything which are greater than the current value, it will go and update the previous list array. So what is the top of the previous list? What will be the value coming here? What is the top of the stack right now? So 0, so this will be 0. Now it will go and update. Now this will go and update the stack, so we're gonna put here 3 and 3. Now we have 4. So 4, this is false because the current value is less than the 4, so the 3 is less than 4. So again it will go in this way and it will update here, which is right now top is 3, so 3, and then the it will go and update the stack. After that, this is 4 and 4. Now the last index is the 5, and the value is 1, so it is true because the 1 is less than the top of the stack. So we are gonna remove all the value which are greater than the our current index. So we're gonna remove this guy. These are already removed. These two are already removed. So even this guy. So now the stack is empty. So it will go. Stack is this is done. Then it will go here. Will update. So the stack is empty. Then -1, and we'll put this value over here, which is 5 1. So at the end of you will see the stack has just 5 1, and we are able to fill the previous list. If you see previous list, so just take an example of 9. So 9 is at index 2. 9 is here at index 2. What is 9 is at index 2? What is the less value? How far is the less value? So where is the less value? So the less value is at index 1, which is 8. So over here is 8. So if you see 8, so same way, where is the less value for the 3? If you see where is the less value for 3, so 3 is at index 3, right? So if you here 3, where is the less value of previous less value of 3? So is at index 0. So what is at index 0? 2. So now we see that this all the previous less, this indicates where are the lesser value of the current one at which index. So if it is saying 3, means at 4 index is what? 4. So the lesser value of 4 is at index 3, so which is at over here, which is the value is 3. So in this way we able to fill the previous list. Same way we are gonna fill the next list and next list. So if we are here right now, we are looking for this side. In the next area we are gonna fill, we are gonna look that side, where in the same way we are gonna fill with the same logic. So here is the pseudo code for filling the next list. So in this time we are going from the right to left. So only difference, the logic is the monotone stack logic is same. Just while filling, when it is empty, we are going to put the length, else the top of the stack value. So now we have for array we have a previous list and the next list. So for the 2, where is the previous list? It's -1, which is like this is the lowest one, and the next list is at 5, which is 1. This is the 5. What is that? 5 index 5 is 1. So this is the way. Now let's calculate. How can we calculate using using these two value, previous list and the next list. So the as we discussed, right, we have this could be the formula, like array I multiplied by I minus previous list at I multiplied by next list at I minus I, and this could be a negative, right? So we have to do the mod also. So if we'll put the value, what is I is 2 multiplied by 2 minus previous list. What is the previous list? Minus 1, and then multiplied by what is the next list? At I, what is the value? 5. So 5 minus I, what is I is 0 right now. So this will give 2 multiplied by 2 into 5 equal to 20. So basically this one, this is 10, right? So we can make 10 sub array using in which 2 will be the minimum. So this will be the 10 sub array, 2 will be the minimum, and if we'll multiply by the current value, which is 2, then it will give me the what will be the sum of minimum sum of those array. So 10 sub array. So if you'll see, it will be 2, then 2 8 8, and then 2 8 9, and then 2 8 9 3. So 1 2 3 4 and 2 8 9 3 4 5. So these are the 5 arrays, and the minimum value is 2 in each one. So that's all.